This is a brief tutorial to show how to make your scaled measurements on a geologic timeline or any kind of timeline. The example that I'm going to use here is for the exercise, homework exercise plotting events in your lifespan. In order to start with this, one of the first things we've got to figure out is what the scale is. And so the instructions for the assignment said that you should plot events from your lifetime over 10 centimeters, right? And again, using the example that from that exercise, my example is going to start with being born in 1990 and ending in 2020. So to figure out the scale for that, we're just going to measure out how many years it takes to cover that 10 centimeters, right? So another way of saying that is 10 centimeters will cover 30 years of time here. And again, I get that from subtracting or taking the difference between 2020 and 1990. Right, we're going to use the scale throughout this exercise, and that is going to be a fixed thing, so we'll come back to that a lot. To get started, we will choose your first event, and this is really simple. You're just going to put it at one end of your timeline. I'm starting it here on the left and moving to right just because that's kind of how our brain works with time. So I have 1990 here at the very beginning, and this is going to be another important reference point that all of our other measurements will be based off of. All right, so our second event is learning to ride a bike. In order to, or at least the first thing that we want to think about here is how many years do we need to cover on this timeline? So to figure that out, we're just going to look for the difference again between the event and when you started. So that's going to be 1996. That's when I learned to ride a bike, and 1990, which was when I'm saying that I was born. So the difference between that is 6 years. So another way of saying what we need to do here is figure out how long is 6 years on this timeline. That's the next step. In order to figure this out, we have to go back to our scale. And to figure out the length that's equivalent to 6 years, we're going to have to do a little bit of math. And this math, I want to walk you through it, is like a conversion. So this is a handy way of going through or at least converting numbers and units that you're going to use routinely throughout this semester, or at least through this class. So we're going to take 6 years, and we want to convert that to distance, basically. And we can do that by multiplying, right? So we're going to build a fraction. We're going to build an equation here that's going to help us convert years to distance. Now in math, you're allowed to multiply or add numbers or add things to an equation as long as that number, or as long as whatever you're adding equals 1. And so one convenient way to do that is to build a fraction. So we're going to build a fraction here and multiply that by our time, 6 years. But the key thing is you can only do that if your fraction equals 1. Now in this case, because of our scale, we're saying our scale is equal to each other, right? We're saying that 10 centimeters is equal to 30 years. So mathematically, that's 1. So we can insert kind of our scale here into our equation, and that's why you're allowed to do that, is because everything is going to be equal to 1 here. I like to start when we're doing these conversions and building your fractions. I like to start in the bottom, in the denominator, and I like to start with that because what we're trying to do is get rid of this unit, the years unit. And if you put that years unit in the bottom here, again, you're dividing years by years, which means you're dividing by the same thing, so that's 1, so they cancel out. So we're going to start building our fraction here by saying, by putting our 30 years in the bottom. That's the time span that we're covering, and then the top of our fraction, we're going to put our distance, which is 10 centimeters. Okay? Another way that we can write this, put this all together into one bit is to 6 years times 10 centimeters divided by 30 years. And again, if you do this, if you just look at the units first, the years cancel out and you're left with centimeters. Again, when I'm doing these types of conversions, I like to build the fraction. I like to first, then second, I like to look at the units to make sure that the units all cancel out and we're left with what we want. And if all of that works out, then I resort to then the third thing I do is the math. So we're going to multiply here 6 times 10, and then you're going to divide that by 30, and you're going to get 2 centimeters. So what that means is that with this scale, 10 centimeters is covering 30 years, 6 years of time is represented by 2 centimeters of distance. So now we go up to our timeline, and we're going to start here at our pinning point, at our starting point, and we're going to draw a line that is 2 centimeters long, and we're going to mark that with our time, 1996, and then our event here. Okay. So let's look at our third event. All right, just to, and I'll walk through this a little bit faster, but our third event, again, is when we graduated from Bruton High School. That is true, not in 2008, but the point here is that we need to first figure out how much time we are trying to show on this timeline. So we're going to take the difference between the event and our starting point. Again, the event is 2008, our starting point is 1990, that's 18 years. So we know we need to figure out how long is 18 years. So in order to do that, we go back to our scale and our math, we build our fraction. You'll notice again that this fraction is always going to be the same for this exercise, 10 centimeters distance on top and 30 years time on the bottom. Those units cancel out, and what we end up with when we do that math is 6 centimeters. So what that means is that in order to show, or the 18 years of time on this line is equivalent to 6 centimeters of distance. We can think about that too before we plot it. Does that make sense? And that should, because 18 years is a little bit more than halfway of a 30-year timeline, right? Halfway would be 15, so 18 is just a little bit more than 15. And since our scale here is 10 centimeters long, 6 centimeters is a little bit more than half, so these numbers make sense. Next step then again is to start at our starting point, and you draw a line 6 centimeters long, and you mark it with the time and the event. Hopefully this helps see the process again for converting time to distance. This will be the exact same process that you follow for the geologic timescale, creating the scaled geologic timescale. The numbers and the scale, of course, will be different, but the format and the sequence here, first finding the number of years you need to plot, and then converting those years, that time, into distance using your scale. Hopefully this helps. I'd love to get your feedback about this, and let me know how else I can help.